All right, let's talk about something called the Model Context Protocol, or MCP for short. In this guide, we're going to break down how it works and really build an intuition for why it could be an absolute game changer for your next AI application.
So let's get things off with a problem that I'm sure every engineer watching this has run into. You've got this powerful large language model, and you need to connect it to all your other stuff: databases, APIs, files. How do you actually do that in a way that's not just a messy hack, but is actually secure and won't fall over the second you try to scale it?
Well, this is exactly the problem MCP was designed to solve. It introduces a really simple but incredibly powerful architecture. Let's meet the three key players that make it all work together so smoothly.
First up, you've got the host. Think of this as the brain of your operation. It's your main AI application, the central coordinator that's running the show, managing all the moving parts, and, really importantly, handling all the security and permissions.
Okay, so for every single one of those external systems the host wants to talk to, it spins up a dedicated client. Now, a client has exactly one job: to manage a single, isolated connection to one server. That one-to-one relationship is absolutely key for keeping everything clean and secure. And that brings us to the third piece of the puzzle: the servers. These are your specialists, your modular building blocks. You might have one server for hitting a weather API, another for accessing your file system, and another for querying a database. Each one is a self-contained expert at what it does.
So let's just quickly put that all together, right? Your host application is the manager. It oversees a bunch of clients. And each of those clients has a dedicated, stateful one-to-one connection with a single server. It's this beautiful, clean separation of concerns that makes the whole system so robust and easy to manage.
Okay, theory is great and all, but where this really clicks is when you see it in action. So let's walk through the entire life cycle of a single tool call. We're going to follow the messages back and forth and see how this actually works under the hood.
The whole back and forth can be boiled down to four main steps. First, there's a handshake where they get set up. Then the client figures out what the server can do. After that, it actually calls a function. And finally, it can even get live updates if anything changes on the server side.
All right, let's get into the nitty-gritty. Everything kicks off with this initialized request. This is that handshake. The client and server basically say, "Hey, can we talk?" They agree on a protocol version and, super importantly, they declare what they're capable of. This negotiation up front makes sure they're on the same page from the get-go.
So once they're connected, the client could ask a very simple question. So, what can you do? And it does that by sending this tools/list request. Super straightforward.
And the server comes back with, essentially, its menu of services. It sends a list of all its available tools. And for each tool, you get everything you need: a unique name, a nice description for what it does, and a JSON schema that spells out exactly what inputs it needs. No guesswork.
And here's where the magic really happens. The client, or more likely the LLM directing the client, can now decide to use one of those tools. It just calls it by name and provides the arguments, like the location here, which have to match that schema the server sent over earlier.
The server goes off, does its thing, in this case getting the weather, and then sends back this nice, clean, structured result. Your AI application can then take this perfect little piece of data and feed it straight back into the model's context to inform what happens next.
Now, this is one of my favorite parts, and it really shows how dynamic MCP is. What if the server's tools change? Maybe a new API endpoint comes online. Well, the server can just send out this little notification. The client gets it and knows, hey, I should ask for the tool list again. It's always up to date automatically.
Okay, so we've just done a deep dive on tools, but that's actually just one piece of the puzzle. It's just one of three core building blocks that a server can provide. Let's zoom out and look at all three of them: tools, resources, and prompts. And what's so smart about this is how control is split up. Tools, as we saw, are actions that are controlled by the model itself. It decides when to call them. Resources, on the other hand, are things like files or emails that your application controls to provide context. And then you have prompts, which are basically user-controlled templates, kind of like slash commands, for kicking off common tasks.
So you might be asking, why go through all this trouble? Why this specific design? Well, it all boils down to a few core ideas, a philosophy, really, that makes your life as a developer way, way easier.
First and foremost, servers should be ridiculously easy to build. Because the host is handling all the complicated orchestration, you can just focus on building a small, simple server that does one thing and does it really, really well. Next up, composability. Because every server is its own little self-contained unit, you can mix and match them like Lego blocks. You could build a travel agent app by just plugging in a flight server, a hotel server, and a calendar server. They all just work together, seamlessly.
Okay, this next one is a huge deal, especially for security. A server only ever sees the information it needs for one specific task. It never, ever gets to snoop on the entire conversation history. This creates a really strong security boundary between your components.
And finally, MCP is built to grow with you. That whole capability negotiation thing we saw at the beginning means you can add new features and new servers down the line without breaking anything that's already working. Your system can evolve.
So there you have it. That's the core idea of MCP. It's a pattern for building powerful AI apps out of simple, secure, and composable parts. It handles the complexities so you can focus on being creative. And that really just leaves one question, doesn't it? What modular AI app are you going to build first?